Ever look in the mirror and think, whoa, how did this happen? I mean, not just you specifically, but life itself.
Yeah.
We're talking about the whole shebang, trees, butterflies, mushrooms, even that weird mold in the back of your fridge.
Right.
It all came from somewhere.
That's right. And the story of where we all come from is more mind-blowing than any sci-fi movie you've ever seen. Today, we're taking you on a journey back through time, billions of years, to uncover the origins of life itself.
We're going to be time travelers today, tracing our ancestry back to the very first ancestor of every living thing on Earth. It's like having a family reunion, but the guest list includes every single creature that's ever existed.
And you'll be surprised to learn just how much we all have in common, even with those distant microscopic relatives.
Okay, so let's start with us, Homo sapiens. We're pretty cool, right?
Yeah.
We walk on two legs, build skyscrapers, and write podcasts about, well, ourselves. But all of this didn't just pop up out of nowhere.
Of course not. To understand where we come from, we need to rewind the clock about 6 million years. Back then, our primate ancestors were swinging through trees, developing social structures, and laying the foundation for everything that makes us human.
So think about it. Those early primates hanging out in the forest were the OG social media influencers. Their communication, their hierarchies, it all shaped how we interact today.
And a key development that set the stage for our complex social behavior was the evolution of parental care in mammals. We need to go back even further, about 200 million years, to see this in action.
200 million years ago. Dinosaurs.
Right?
You got it. While T-Rex was stomping around, our tiny furry mammal ancestors were evolving a revolutionary strategy. Live birth and milk.
Talk about a game changer. Suddenly you've got moms taking care of their babies for longer periods.
Right.
That leads to longer lifespans, stronger bonds, and eventually the foundation for complex social structures. Exactly. Those early mammals with their fierce maternal instincts were paving the way for us to become the social butterflies we are today. But we need to keep rewinding, going way, way back.
Lead the way. I'm ready to see what's next on our evolutionary road trip. Where are we headed?
Fasten your seatbelts. We're diving 500 million years into the past, to the ancient oceans teeming with life. And here's where we meet some true pioneers. Fish with the audacity to crawl out of the water and onto land.
Fish. On land. Sounds fishy to me, but how did they manage that?
Well, they were starting to develop something pretty important. Limbs. Their fins were slowly evolving into legs, setting the stage for vertebrates to conquer the land.
Vertebrates. So these fish, the OG land explorers, were our great times a million grandfathers, giving us the backbone to stand tall and conquer the world literally.
It's amazing to think about, isn't it?
Yeah.
We owe a lot to those brave fish who dared to venture onto land. They were paving the way for everything from dinosaurs to, well, podcasters, but our journey doesn't end there. We need to go deeper, back to the very foundation of life itself.
Okay, so we've gone from primates to mammals to fish crawling onto land. I'm guessing things are about to get really microscopic. Where are we headed next?
Get ready to zoom in because we're going back over 3 billion years to a world dominated by single-celled organisms. This is where we meet the tiny but mighty cyanobacteria pumping out oxygen and changing the planet forever.
Cyanobacteria. So like pond scum. Those little guys were responsible for the air we breathe.
Yep. They were the original eco-warriors, transforming the Earth's atmosphere and creating the conditions for more complex life to evolve. And it's all thanks to the magic of DNA, the blueprint of life starting to work its wonders.
We're talking about the origins of life here, the very building blocks of everything we see around us. I'm feeling pretty small all of a sudden. But is this as far back as we can go? Is this the beginning of the story?
We can go even further back to a time when the Earth was a wild and chaotic place about 4 billion years ago. This is where we encounter something truly remarkable. LUCA, the last Universal Common Ancestor.
LUCA. I've heard whispers about this mysterious ancestor. Tell me more. What was this LUCA like?
Imagine a world of volcanoes, meteorites, a hostile atmosphere. Not the most ideal vacation spot, right? But in this extreme environment, life found a way. LUCA emerged probably in the depths of the ocean, perhaps near a hydrothermal vent. And from this single-celled organism, every living thing on Earth descended.
Wait a minute. Are you saying that every single thing alive today, from a redwood tree to a blue whale, to me is related to this one tiny cell?
Exactly.
My mind is officially blown. So what made LUCA so special? What secrets did it hold that allowed it to give rise to all of this incredible diversity?
Well, that's a question for our next chapter. We'll delve into the remarkable features of LUCA and explore how its legacy lives on in each and every one of us. Stay tuned. Welcome back to our deep dive into the origins of life. Before we went on our little side quest, we were about to meet LUCA, the last Universal Common Ancestor, the ancestor of literally everything alive today.
I'm ready to learn more about LUCA. I want to understand what made this single-celled organism so special, so groundbreaking, that it sparked this whole crazy explosion of life we see today.
Well, imagine Earth 4 billion years ago. It was a wild, wild place. Volcanoes erupting everywhere, meteorites constantly bombarding the surface, and an atmosphere full of toxic gases. Not exactly a walk in the park.
You're kidding. Sounds more like a death trap. It's hard to believe anything could survive in those conditions.
But life is incredibly resilient, and it found a way. It's in these extreme conditions, most likely in the deep ocean, maybe near those hydrothermal vents spewing hot mineral-rich water, that LUCA emerged.
Okay, so LUCA was one tough cookie. You could handle the heat, the chemicals, all of it.
Yeah.
But was it actually the very first life form? Or was there something even more ancient lurking around?
It might not have been the absolute first, but it's the one we can trace everything back to the great-great-grandparent of every bacteria, archaea, and eukaryote. That last one includes all plants, fungi, and of course, animals like us.
Wow. Talk about a massive family tree.
Uh-huh.
So what exactly made LUCA so special? What tools did it have that allowed it to become the ultimate ancestor, the root of all life?
LUCA had the essentials for life as we know it. Think of it like a basic starter kit, but for creating life. The first tool in its kit was ribosomes.
Ribosomes. Remind me, what are those again?
Ribosomes are like tiny, incredibly complex machines inside cells. They build proteins following the instructions encoded in our DNA. Proteins are the workhorses of the cell, doing pretty much everything a cell needs to survive and function.
So ribosomes are like the construction workers of the cell, building all the essential structures. Pretty crucial then. What else was in LUCA's starter kit?
Next up, DNA and RNA, the molecules responsible for carrying genetic information from one generation to the next. You can think of them like the instruction manuals for building and running a living organism.
Right. DNA and RNA, the blueprints of life. LUCA had the construction workers, it had the blueprints. What else did it need?
Well, you need somewhere to store those blueprints and workers, right? A safe place to keep all those complex processes running. LUCA also had a lipid membrane, a sort of protective barrier that enclosed its internal machinery, shielding it from the harsh environment outside.
So it was like a tiny self-contained world, keeping all the essential processes for life safe and sound inside. Pretty impressive for a single-celled organism.
Exactly.
Right.
It's like a microscopic city bustling with activity, all contained within a protective wall. And LUCA, with this essential kit, thrived and reproduced, passing on these traits to its offspring. Over billions of years, its descendants evolved and diversified, eventually leading to the amazing variety of life we see today.
It's amazing to think that all life on Earth today is essentially a remix of LUCA's original recipe. But if LUCA lived billions of years ago, how do we even know it existed? I mean, we don't have any fossils of LUCA lying around, do we?
That's where the beauty of science comes in. While we might not have fossilized remains of LUCA itself, we have something even more powerful: the genetic code.
You're talking about DNA sequencing, right?
Yeah.
Like cracking the code of life itself.
Precisely. By comparing the genomes of different organisms, we can trace back their evolutionary relationships and identify common genes that have been passed down through generations.
So it's like a giant puzzle using the DNA of living things to piece together the story of LUCA. It's like being genetic detectives. But how do we know for sure that these shared genes actually point back to a single common ancestor?
That's a great question. One of the most compelling pieces of evidence is the near universality of the genetic code. Remember adenine, thymine, cytosine, and guanine, those 4 bases that make up DNA?
Oh yeah, the famous A, T, C, and G. I remember those from biology class. But what do they have to do with LUCA?
Well, these 4 bases, this alphabet of life, is virtually identical across all living things. My DNA, your DNA, the DNA of a sunflower, even the DNA of a bacteria, all use the same basic code. It's the same language, a direct link back to LUCA. This universality is incredibly strong evidence for a single common ancestor for all life on Earth.
Whoa, hold on a second. So you're telling me that a part of me at the most fundamental level is billions of years old? That's a pretty wild thought.
It is a profound thought, isn't it? It's almost like carrying a tiny piece of that first spark of life, a legacy passed down through countless generations. And this ancient code isn't just a relic of the past, it's still shaping the world today.
Okay, wait. If LUCA was so simple, just a single cell, how did we go from that to all the mind-boggling complexity we see in life today. I mean, we've got everything from microscopic bacteria to giant sequoia trees to, well, podcasters pondering the meaning of life.
That's the magic of evolution. Over billions of years, those simple building blocks were rearranged, modified, and combined in countless ways, leading to incredible diversity. LUCA's descendants adapted to different environments, faced different challenges, and then through natural selection, they gradually evolved into the diverse forms of life that populate our planet today.
So evolution is kind of like a master builder, constantly tinkering and experimenting, creating new and amazing forms of life. And this process is still going on today, right?
Absolutely. Evolution is a never-ending story. It's happening right now all around us in ways both big and small. And in the final part of our deep dive, we'll explore how LUCA's legacy continues to shape the world today and what the future might hold for the incredible tapestry of life on Earth. Stay with us.
Welcome back to our evolutionary epic. We've journeyed billions of years from those first single-celled organisms to the rise of complex creatures like us.
Yeah, it's been quite a ride.
But before the break, we were talking about how evolution isn't just some ancient history.
Right.
It's happening right now all around us. So what's evolving now? Are we talking about humans getting superpowers or something?
Well, maybe not superpowers, but evolution is definitely still shaping life, including our own. Think about it like this. The environment is always changing, whether it's a shifting climate, a new predator on the scene, or even the introduction of, say, antibiotics.
Oh, right.
Life has to adapt or, well, face extinction.
Right. Survival of the fittest and all that. But what are some examples of evolution happening in the world today?
One of the most dramatic examples is antibiotic resistance. You've probably heard about this. It's a huge challenge in healthcare.
Yeah, I've heard about superbugs and how they're becoming resistant to the drugs we use to fight infections.
Uh-huh.
It's kind of scary, honestly. But how is that an example of evolution?
It's a perfect example. Think of it this way. Every time we use antibiotics, we're essentially setting up a competition for bacteria.
Okay.
The ones with random mutations that make them resistant to the drug survive while the others get wiped out. The survivors then reproduce, passing on their resistance genes to their offspring.
So it's like we're accidentally training bacteria to become supervillains.
Yeah, in a way.
It's not just bacteria, though, right? Are humans still evolving, too?
Absolutely. Our own genomes are constantly changing, though, at a much slower pace than bacteria.
Okay.
It's not like we'll wake up tomorrow with X-ray vision, but over long periods, these subtle genetic changes can add up.
So what kind of changes are we talking about? Is there anything we can actually see in humans today that's a result of recent evolution?
There are some fascinating examples. Some populations living at high altitudes have evolved genetic adaptations that allow them to thrive in low-oxygen environments.
Wow.
And in some parts of the world, people have evolved to efficiently digest certain foods that were traditionally important in their diets.
So evolution isn't just about growing extra limbs or developing superpowers. It's about subtle changes that help organisms adapt to their environment.
Right.
And these changes are happening all the time, even in us. That's pretty amazing.
It is. And as environments continue to change, whether due to natural processes or human activity, life will continue to adapt and evolve. That's the beauty and power of this process.
So what does the future hold for evolution? Can we predict what life will look like in 1,000,000 years or even 1,000?
That's the exciting part. Evolution is inherently unpredictable. There's no telling what new challenges and opportunities life will face. New species will emerge, others might fade away. The only certainty is that life will find a way.
It makes you realize that we're just one chapter in this incredible story of life on Earth. A story that started billions of years ago with LUCA.
Exactly. This whole journey from those first single-celled organisms to the incredible diversity we see today is a testament to the resilience and creativity of life.
It's humbling and awe-inspiring to think that we're all connected, sharing a common ancestor with every living thing on this planet.
So the next time you look at a tree, a bird, or even the mold in your fridge, remember this. You're looking at a distant relative, a fellow traveler on this incredible journey of life. We are all part of something vast and interconnected, a web of life stretching back to that very first spark, LUCA, and the story is still being written